you. Okay, so guys, remember, the only thing you're allowed to multiply an expression by without changing the value of that expression is 1. Like in the previous problem, we said, hey, we've got to multiply by 3 in order to introduce that du into the expression. So in the same step, we divide by 3, right? All right, so here, if I multiply by a -1, okay, I can compensate for that by multiplying by another -1. All right, so we end up with the opposite of the integral. So the -1 x squared over dx, I always circle the du. So that all disappears and gets incorporated into that du. So I have e to the u with respect to u. And now we ended up with something we can integrate. So we chose the correct u. All right, what is the antiderivative of e to the u with respect to u? So we have negative e to the u. What do we have to have on every indefinite integral? Plus c. All right, and the last thing we'd want to do is go ahead and make that u substitution. So our final answer would be negative e, so 1 over x, plus c. Because e is for easy. So don't skip these exponential problems because you might be cheating yourself out of points. It looks scary. Okay, it did. We get a fraction and a fraction as an exponent, but try something. Okay, try something. All right, so look at this one. Integral 1 over 2x minus 1 with respect to x. So do we need a u sub here? Here's what we know. So if we integrate 1 over x with respect to x, what do we get? Natural log absolute value of x plus c. Y'all done this? Or if I have 1 over u with respect to u, we get natural log absolute value of u plus c. All right, so my integrand doesn't look like either of these. So let's try u sub. What do we want to call u? So u equals 2x minus 1. All right, so what's du? du equals 2 dx. All right, so I know that the u sub will work as long as I see the variable component of that derivative in my integrand. We got the dx, we're just missing the 2. We can handle a missing constant. All right, so in order to introduce du into this expression, we need a 2. So if we multiply by 2, what do I have to do in the same step? Divide by 2, okay? Multiply by 1/2. Okay? So the 2 and the dx, it's going to disappear because it gets incorporated in that du. So 1/2 integral 1 over u du. So now I have something that we can integrate. So what is the antiderivative of 1 over u with respect to u? So 1/2 natural log absolute value, don't forget absolute value, of u plus c, and what was u? 2x minus 1. So I went ahead and made that u sub. Everybody okay? All right, so the craziest thing will happen. We do a lot of this natural log anti-differentiation. But remember, when you take the derivative, little mini lesson here, review. When you take the derivative of natural log, what is that derivative? Derivative with respect to x of natural log u? 1 over u times u dx. I just copy the argument in the denominator and then its derivative right on top. Okay? Now, a couple years ago, question number 1, multiple choice question number 1, on the AP exam was 1 over x squared with respect to x. One of the distractor answer choices was natural log of the absolute value of x squared plus c. Many students got fooled by that, okay? And this is actually one of the top 10 mistakes on the AP exam. People, when students, and it happened in my class already this year, 1 over something, they think, oh, natural log antiderivative. No. Okay? It has to be a situation where we can take this denominator and see the variable component of its derivative in the numerator. What's the derivative of x squared? 2x. It's not a natural log antiderivative. Okay, so be careful there. Just because it's 1 divided by something doesn't guarantee it's going to be a natural log antiderivative. Okay? All right, so look at this next one here. Try something. Try it. Oh, that's so good. Oh, I thought I was sharing a pencil. Here. He was using his eraser. I thought it was like, your turn, your turn. All right, notice anything? I mean, because so some people could go straight to the answer here if you recognize this denominator, okay, the derivative of the denominator, is sitting right there in the numerator. So this is a situation of du dx over u. Okay? But I'm going to go ahead and do the u-sub process. So u equals x cubed plus 3, or sorry, plus x. So then du, we have 3x squared plus 1 dx. And hey, that works out nicely. I don't have to multiply or divide by anything. So there's my du right there. So 1 over u du. That's fine. That's the same thing. Same thing. Du over u is fine too. Sometimes they'll present 1 to you that way. So you got to recognize that that is equivalent. All right, so what is the antiderivative of 1 over u with respect to u? Natural log. That's the value of u plus c. But what was u? X cubed plus x. Okay.
So, I remember the second question she told me to remember because I didn't remember it being a problem for me. But the first one was, I have trouble like with C. I always get like mixed up with like comparison. Would I get points taken off if I said W instead of U, but at the end I put like U?
And sometimes we can overlook it. I would think in this problem, because there's no W's, anything W about it, they would probably read it as a U. Like just say, oh, he has sloppy handwriting. His U's look like W's. But if there was like multiple functions and we had a function named W, and you use W incorrectly somewhere, then that would be an issue. Did that answer your question? They used to let us like T's and X's, turn your head, the T's look like X's, you could overlook it, but they're getting a little bit pickier about that. But I think like if a U looked like a W at one time, we would probably ignore it.
What was the other one, Miss? I didn't remember it being a problem.
Yeah, I don't think remember it was that big of a deal maybe, but it might come to me if she doesn't.
Okay, are we skipping this next one?
Yeah, we can skip that.
Okay. So skip the next one, go to the one at the bottom. All right, what are we going to try? The denominator? Okay, let's see what happens. So u equals, we'll call it that denominator, e to the x plus 5. All right, so what's du? E to the x dx. Well, that's convenient. I've got e to the x dx. So integral 1 over u du. So antiderivative, natural log, absolute value of u, plus c. What's u? E to the x plus 5. So guys, that was another situation that was set up similar to that previous question. If you look at your denominator, what's the derivative of that denominator? E to the x, the numerator. If you would have recognized that, no, you could have gone straight to that right there. Now, the whole process doesn't take that long, so I tend to make mistakes if I skip too many steps, so I'd probably go through the process. Good? What's next? All right, try the next one. Sorry. Do it. I don't know. I feel like they got this. I wonder if we should do this one. Okay. Stop making so many mistakes. Okay, can I tell you what I see on your paper? Okay, so read that to me. Because this would be an issue. You've actually introduced two. So you see this? If I read this, what does that look like to you?
1/3 minus cosine.
Do you see that? What should it say?
Negative 1/3. Which is why, did you see me like?
You
erase this
clarified it
over
here. Yes, you did. So this is a situation where you have something, but you clarified it. But this is not equal to this, because when we read this, we see it as 1/3 minus cosine u, even though in your head you meant times, right? And clearly you did because you clarified it here. But now you have a misuse of equality. So we would have to take a point off somewhere. So that's what my kids say. They'll be like, you know what I meant. Well, no, it's not about what you meant, because you're not going to be there saying, that's not what I meant.
Yeah, but that's what I got.
But you're saying, without those parentheses there, if I picked up a calculator and I plugged in this into a calculator and plugged in this into a calculator, they would not match. So this is actually called a misuse of equality, because you made the statement that two things were equal when they're not in fact equal. I just want you to be aware so that doesn't happen to you. All right, so we all chose u equals x cubed. So du equals 3x squared dx. All right, so as long as we have the variable component of that derivative as part of our integrand, then u sub will work. So what are we missing? We've got the x squared, we've got the dx. What do we need? In order to introduce du, we multiply by 3. So if I multiply by 3, what else do I have to do? In the same step, divide by 3, multiply by 1/3. So really we're just multiplying by 1. So the 3x squared dx is going to disappear because it becomes that du. So we have 1/3 integral sine of u du. So what is the antiderivative of sine u with respect to u? Negative cosine? Okay, no, carry on. All right, so I know my antiderivative would be negative cosine, so I'm going to write this as negative 1/3 cosine u plus c. But don't forget as a final step, if this is a free response question, to go ahead and make that u substitution. So negative 1/3 cosine u plus c, where u was x cubed. Everybody okay there? How could we check our answer? How could we check that answer? What if I just wanted to like check my answer? How could I check my answer? Take a derivative. If we took a derivative of our answer, what should we get? The integrand. Okay? So think about it. Remember we talked about like they undo each other? So just for fun, let's do that. Just for fun. We all like math. So if I'm taking a derivative, x cubed, of my answer. All right, so what's the derivative of negative cosine? Sine. So we would have negative 1/3. Or sorry, negative 1/3 times negative sine. So negatives divide out. Leave the inside alone. Times derivative of the inside. What's the derivative of x cubed? 3x squared. And what's the derivative of any constant? 0. So clean it up, your 3's divide out, and you're left with x squared sine of x cubed, which was our original integrand. Okay. All right, so some of you are already working on the next problem.
Why is 1/3 negative?
Where? Right on this one? So I use this like just as a visual. So if I'm taking derivatives, we go down. Did you answer her question? Okay, so we were taking the antiderivative of sine. Okay, so if I'm taking antiderivatives, I go up. So one step up would be negative cosine. Okay, and then when I take a derivative to check my answer, I go down, which is why we got back to positive sign. Did you have a question? Okay, on the next one? All right, let me erase this because I've used this space. All right. Okay, they already started on the next problem. So guys, let's work that next problem, and then let's go back to the one we skipped. Okay, so here's what I would do. If you want to call this u, let's see what du would be. I would end up with 4 cosine cubed 3x times negative sine 3x times 3. That would be your du, if you call that u. So I don't have much of. Yeah, so I think we made kind of a mess. So this is an example of, okay, let's try something. Maybe it didn't work. Try something else, okay? All right. Can I erase this? I would do a rewrite step. And I would say, you know what? This is cosine 3x to the 4th power times the sine of 3x. Well, think about if I was using chain rule, or if I was taking a derivative. Would I need chain rule? Yes. What would be like the inside piece? That right there, the cosine of 3x, because the derivative of cosine 3x is negative 3 sine 3x. And I got that right there to work with. Where's my pen?
Sounds good. Somebody's got to try something. Just try.
Oh,
I
yeah.
tried it didn't work, so that's good.
So we moved the 4 to the outside, so now we have
So it actually looks more like an exponent, and it
So
will
now,
make more sense.
I see where we're going with this.
Yeah, there we go.
Yeah, I would not neglect the importance of that rewrite step. hope you don't get a new board. Because your board is awesome. We just got the new boards.
Oh, it's not good. Sorry, you don't like it. You have the original.
Yeah. But mine was one of the rare ones that were still working. It just takes some getting used to. Like if you get too close to it, it writes. I mean, you could be like, because it's a touch screen with your finger. Like today, like my jacket was scraping against it. It was. You can write with your finger, and there's a pen.
My biggest problem with this one is I lean, and when my badge hits it, it makes like crazy.
That's funny. Oh, I didn't. Okay, I don't think you didn't integrate. So go back to this stuff and take an antiderivative. You see that? Okay, when you got right here, you took a derivative instead of an antiderivative. Yeah, there, divided by 5. Your handwriting is so neat. Neat. Okay, so we all got the right U, right? We all got the correct U, so if I call, did you say wait? Okay. All right, so U equals cosine 3x. Now, guys, I would rewrite this. I wouldn't neglect that rewrite step. When you see the exponent after the operator, you have to understand that what you're really raising to the 4th power is that whole cosine ratio. And just side note, you can't type it into the calculator this way, because this happened in my class a couple days ago. They were like, oh, it's giving me an error. And when I looked on their calculator, they were trying to put the exponent right after the operator. That doesn't make sense. So you're actually taking that cosine ratio and raising it to the 4th power. So I wouldn't neglect that rewrite step. Okay. So now I can see what's really the inside piece. And if I just think about this mentally, I know the derivative of cosine is negative sine. I've got that to work with. Okay. So U equals cosine 3x du, negative sine 3x dx. I've got that variable component as part of my integrand. Only thing I'm missing is the negative 3. We can handle that. Integrand. Integrand. Is that not a integrand? It's it's this piece right here. Ignore the operator, just like if I was doing this. The x is called the radicand. We don't use that word very much. But the reason why I'm familiar with integrand is because on a scoring guidelines, you have to pay attention to whether it says a point for the integrand or the integral. If it says integral, you got to look at everything, including the limits. If it's the integrand, it's just that. Okay, sorry. Thank you for asking. Okay, so the only thing we're missing is that negative 3, so I can multiply by negative 3 as long as I do what in the same step? Okay, divide by negative 3. All right, so we got the negative 3 sine 3x dx. That all disappears and becomes part of that du. So negative 1/3 integral u to the 4th power with respect to u. So now we've simplified this a lot, right? Okay, and this is where some of y'all kind of went crazy here. I saw y'all taking derivatives, right? So just be careful, or just like forgetting to integrate completely. You did all the hard stuff, okay? All right, so we've got to remember to take that antiderivative. So what is the antiderivative of u to the 4th with respect to u? Okay, so I have negative 1/3 times u to the 5th over 5, or 1/5 u to the 5th, whatever your preference is. And what do I have to have? Plus c. All right, so then if I clean this up and make my u substitution, -1 over 15 times u to the 5th power plus c, where u was cosine 3x.
Oh, I put 4.
Okay, so
Maybe
do,
it's fine, we leave it like that, it's a safe stop.
Uh-huh.
Instead of writing cosine.
oh yeah. Show me. Perfect. That's perfect. So say, show me. Perfect. Yep. Now be careful. It's hard to tell. Okay. The only thing that's hard to tell on yours is that 5. Is it inside the parentheses being raised to that power or not? Just make sure that that 5 is not in those parentheses. I know, it's hard. It's just hard to tell. Just be careful there. Okay. Okay. Guys, do this problem. Do the example from the AP exam. So this is straight off an AP exam, what it looks like as a multiple choice question. So work that last one. Do the multiple choice question. I was going to see, lost your notes. So I was gonna. Can I give them like a little challenge problem? Because I don't think we have time to do that long division. So. Like if this one didn't have the square. So this comes up occasionally. I usually just do like this one problem and I never do it again. But the kid that I tutor, like he had a whole day of lessons on this. I was like, I can't believe your teacher gives you so many of those. So I end up with like x squared of u and then du. We got this x in here causing us issues. So then they have to realize that they have to use that relationship. U minus 3 squared of u. And go from there, like distribute and then integrate.
Yeah, that's great. And I think, yeah, their back is blank, so they got
Okay. What'd y'all get? Perfect. Yep. Correct, yeah. Perfect. Do what? Wait, hold on. You kind of got multiple things going on. Is that an integral symbol? And then you got your plus c. So, yeah, you kind of like did a bunch together. Wait, yeah. So then replace like the 3x squared dx becomes the du, right? So you end up with 1/3 u to the 6th power with respect to u. Then you can integrate. Because
whenever when the
The one thing like as part of this later, but like that, I know it's true because I know you're not doing the like to see how that almost looks like a you know what I mean?
It's so cold outside.
oh, sorry.
Whenever we walk, I was like, it's like pedaling.
Oh. All right, so we all found the correct u. U equals x cubed plus 5, so d equals 3x squared dx. We got the x squared, we got the dx. All I'm missing is a 3. We can handle that. Okay, as long as if I multiply by 3, I divide by 3 in the same step. All right, 3x squared. 3x squared dx is our du. 1/3 integral u to the 6th du. They were fine because they're helping each other. I just want to make sure everybody got there because we were like so close and then tiny little things. All right, and then we can integrate. Don't forget that step of doing the integration. So 1/3 u to the 7th divided by 7 plus c, where u is x cubed plus 5, and then 3 times 7. You can see where that 21 came from. Everybody good? Okay, I want to show you one special type of problem that doesn't appear too often, but you might see it. Okay. Okay, it's going to be very similar to this one. Okay, so copy this problem down on the back, but leave off the exponent. Leave off that square. Trying to find a blank page. You want the answers?
There we go.
All right. So integral x times the square root of x plus 3. So do you see, the only thing I did was I removed that square from what's inside the radical. All right, but what do you think we should do on this problem? Okay, so what would you want to call u? X plus 3? That's what we did on the last problem. You called the u the inside, x squared plus 3. All right, so if we say u equals x plus 3, then what's du? 1 dx, right? du dx equals 1, so du equals dx. So I don't have to multiply or divide by anything. All right, so I have this x that we haven't done anything with, times the square root of u with respect to u. We still have an x in there. That x is in my way. I wish it wasn't there. Can I bring it outside the integral? No. The only thing we can introduce is a constant. The only thing I can legally bring outside an integral is a constant. So that x, as much as it's in our way, we can't get rid of it. You got an idea? What's your idea?
Well, if we turn that x plus 3 into a 1 over x plus 3 squared.
I'm not sure where that would go, but try it.
Okay, I thought I was onto something.
We did too. I was looking at Miss Grant. I was like,
But now I feel like it's Indian, so I'd rather just let you
hey, I don't know. There's a lot of things that are legal. They just don't help us. Okay? Yeah, so there's a lot of things we could do, but we want to do something that will help us. What do you think, guys? The problem is the x. The goal was to get everything in terms of u. But we already made x plus. Hold on. We have the correct u.
U plus 3, or u minus 3.
Wait, what? What?
X equals u minus 3.
I said it louder.
I said it louder. Guys, we have a relationship between x and u. Okay, we defined that relationship. We said, hey, we're going to let u equal x plus 3. This x is in my way. So what if we solve for x in terms of u? Okay, so all we do is subtract. So x is u minus 3. All right, so now we're taking out the x and replacing it with u minus 3. So now I have an integrand that's all in terms of u. But I got to do one more rewrite step before we can integrate. So we do have to distribute that square root of u, or u to the half power. So if we multiply u times u to the half power, we add the exponents, u to the 3/2 power. Everybody okay there? Minus 3 times u to the half power. So 3u to to the 1/2 power with respect to u. Now we can integrate term by term with respect to u. So what is the antiderivative of u to the 3/2 power with respect to u? There you go. And then dividing by 5/2 is the same as 2/5 minus 3u to the 3/2. Dividing by 3/2 is the same as multiplying by 2/3 plus c. Clean it up, make your u-sub. Isn't that a fun problem?
Thank you, Ms. Bruce. We'll all see you on Saturday.
Yes, I can't wait.